Welcome back to the Math Professors. I'm going to cover an initial value problem that's found in Calculus 3, which is kind of a connection between Calculus 3 and differential equations. So we're going to solve the differential equation. The second derivative of the vector valued function r with respect to t is equal to negative 16k, and it has initial conditions where the vector function r evaluated at 0 is 10i minus 15j, and its derivative evaluated at 0 is negative 2i plus 1k. So the question is, how do we solve a differential equation? Or, what is the answer to the differential equation? Well, we're trying to find a vector valued function that has all these properties. So I know its second derivative. I know its first derivative at 0. I also know the function of value at 0. So what we're going to do is we're going to start out with the second derivative, and we're going to compute its first derivative by essentially taking the integral of this. So what we know is the integral of the second derivative of r, with respect to t, dt is simply going to be equal to dr dt. So what I'm going to do is, notation-wise, this is going to be the integral of negative 16, k with respect to t is going to be equal to this, this dr dt. So I know this thing's integral is going to be equal to c1i plus c2j plus negative 16, I'm going to say it this way, I'm going to say plus a negative 16t plus c3k. Now let's make sure that this, actually works. What is the derivative of a constant with respect to I? Because I'm basically trying to, get back to this. Well, the derivative of a constant is equal to 0. Derivative of this constant would be equal to 0j. And then in this case, the derivative of negative 16t is going to be equal to negative 16, and then the derivative of this constant is going to be equal to 0. So that's what we have back. Now, because remember what we have here is this is essentially, 0i plus 0j minus 16k, just to be sure that we can see that they match when they take their derivatives. Okay, so how do we resolve, c1, c2, and c3? Well, I know that this is equal to dr dt. So dr dt, I know evaluated at t is equal to 0 is going to be this function evaluated at t equal to 0. So c1i plus c2j plus, a negative 16 times 0 plus c3k has to be equal to, well, this derivative, this is going to be equal to minus 2i plus 0j plus 1k. So that means C1 has to be equal to negative 2, C2 has to be equal to 0, and then C3 has to be equal to negative 1. So then in general, dr dt, which was this with the correct C values, is going to be equal, like I said, C1, so this is minus 2i. C2 is going to be 0, so this is plus 0j, and then C3 is going to be equal to 1, so plus a negative 16t plus 1k. All right, we're almost done because, remember, I'm trying to find the original function. So what do we do to this again? Well, we know that r of t is going to be equal to the integral of dr dt with respect to t, and that means it's going to be the integral of this. With respect to t. So the way we integrate is, component-wise. So this is going to be equal to minus 2t plus, I already used c1 through c3, so let's say c4. And this is going to be in the I direction. Plus, well, the integral of 0 is just going to be, c5, just a constant. This is going to be j. And then plus, well, the integral of this is going to be minus 16t squared over 2 plus 1t. That's the integral of this, plus a c6 dt. Now, how to resolve the c's again? Well, just like I used this in the previous one, I'm now going to use this to be able to resolve the c's. So very similarly, if I plug in r, remember this is r of t, if I plug in r of 0, this is a minus 2 times 0 plus c4. That's going to be in the I. Plus, c5j, plus, this is minus 8 times 0 squared plus 0 plus c6 has to be equal to that, which is going to be 10I minus 15j plus 0k. And, these are going to annihilate. So again, in order for these two vectors to match, they have to share the same components. So C4 has to be 10, C5 has to be negative 15, and then C6 is going to be equal to 0. So finally, this is our answer. It's going to be, this vector with the correct C's. So our vector value function, R, is going to be equal to minus 2t plus C4, we know is 10. This is going to be I, plus C5, which is going to be a minus 15j plus a negative 8t squared plus 1t plus c6, which is 0. Okay, so if you liked the content, please subscribe.